guy that I got working on the basic transistor circuit is now basically just Frankenstein to run off this 18650 through a USB boost circuit. So that way I can just tug it around portable like and recharge it. But I noticed playing with these using the linear hall sensors, one of the benefits was being able to adjust the output voltage on the sensor, and that gives you the ability to sort of hone things a little bit. In this case, I'm able to more or less, I want to say I could do different things with that, but I noticed, I guess it's just sort of an on-the-fly way to sort of tune it, and rather than use a trimmer, I just found I believe some specific values and threw a 10K pot on there. If I could, I would have used a 5K or maybe a 1K. But it does give me the ability to slightly adjust it. So with it all the way up, if I slightly turn it back, maybe you can see that thing drop down a little bit. So now this thing will still probably hold some weight, but it's not going to hold that one. So you see, like with this one, it'll still hold that one. And see at what point maybe that'll drop it. It might. Yeah, so depending on the weight, so you can see like right now where it's at, it's just barely is too heavy. So if I just notch that up a little bit, it'll start holding it. So there's a relationship going on there that you have to find between all the variables, but I kind of found that to be just a neat way to do it. So maybe if I can ever so slightly try to vary this with it all the way up, you can sort of see the very slight wiggle room it's got. See, it's shaking around too much, but you might be able to see it sort of lowers and raises. So I can lower and raise the distance from there to a certain degree, and all that really does is allow me to put different weighted magnets on there, just so I don't have to use like the same ones. So put like just some random little guys like that in there, and that'll work. Obviously the magnet strength matters too, because that's going to affect your sensor level. So you have to sort of find a ballpark where all the variables match up. So this amount of weight right here almost looks like I'd be able to show it. So with that hanging how it is, I'll turn it up. So you saw how they got a little bit closer. Let me see if I can make it rock up and down. So I'm just slightly varying that potentiometer, and it's causing the magnets to either hang a little lower or hang a little higher. And if I cut it all the way down, I'd imagine they'll just fall like that. So, but this circuit was pretty cool because it didn't actually consume a whole lot of energy, and this thing ran for it was pretty much a whole day before the battery died on me and I had to recharge it. Yeah, well, like I say, the benefit of the sensor, still using a tiny little aluminum strip there, but yeah, I figured that's no big deal. But for about that size, that's pretty cool. Now, I did make another one. I got away with using one coil. But the only thing I didn't like about that was, obviously, it boosted the current, and with that set up in a situation where I didn't have the magnet there to keep the draw down, then it would pull too much through the coil, closer to 400 or 500 milliamps, and that's just too much hot enough to heat up that coil and melt some hot glue or something like that. But the way this runs, it won't happen. One which I actually had put together in a different setup, much smaller. It was a really cool little mini deal that was using the battery power and was rechargeable and everything, and it was pretty sweet. But then I messed up something with it and got frustrated, and just decided to try something else. So this is another similar one that I've done, and It's got the magnet down here on the bottom, which I found was going to be necessary. I'm using the air core again right here, little double stack of these magnets around. But basically what I'm doing is I'm playing with the switching of this transistor, just varying the voltage that's fed into it at a particular distance from the sensor, or the particular magnet distance from the sensor. And I'm basically just watching it on a scope, and I'm watching the voltage drop, and trying to very finely adjust that voltage to offset the sensor. So whereas in this case the sensor is going to see about 2.5 volts on the output, or that's what the transistor is going to see into the base, about 2.5 volts from the Hall sensor output. Unless you drop that. In this case, what I can do is I can, at the steady on state with that set resistance, the transistor is going to be on at about, let's say about 1.4 volts or so with this tip 120. And at that 1.4 volts, it's going to be driven at a certain current. And when you drop the magnet down, of course, depending on the polarity, in this situation, moving the magnet closer, I'm having the output voltage drop. So it's going to drop to a point where that transistor cuts off, slowly starts to, it'll cut completely off, but then after that, it'll have like it won't be a complete cut off, but it'll mainly shut off and have a tiny little bit of pull after that, down to a certain point. So that's basically what you're doing. I'm honing the voltage, at which point I bring it down and I can see that I'm getting relative balance. So I'm basically just using this pot down there, 50K pot. But once I find the general spot, then I go ahead and replace that 50K with a trimmer, and then fine tune the value from there where it's best at. And then I leave that trimmer where it's at, and then I throw another trimmer, maybe 5-10K in series with it, backing off the main trimmer a little bit, and then I use that second 10K trimmer as a more of a fine tune adjust, so I can finally attune within a 5-10K range at that point that I had, at that region I had tuned earlier. And that basically gives me the ability to really finely tune what's going on, so I'm not just dealing with these very low tolerance variables that I'm having to tune just using just general distance and spacing, and that's not going to work unless you get real lucky or you're dealing with a lot of current output where you have that leeway. But that's basically what I'm doing here, and in this situation I needed to throw this magnet down in here, and it just so happened to be the perfect distance in this container where I set this on top of it, to where it throws off it offsets the forces I need going on to make this happen. So now that I've got it running, I can basically take that 10K trimmer and trim it up or down, where turning it up is going to, or let's just say rotating it one way is going to decrease the resistance and pull more power through the coil. Essentially turning the transistor on a little bit harder, and then the other way obviously is going to do the opposite. So right here I can basically, with this setup, because I've got that inner magnet down below and this magnet ring above, I can move this magnet ring around in relation to that center magnet below to get it to sit perfectly center. That way I don't have to play with all those freaking magnets. I can leave them how they are and just move this around to get it to the point where it's perfectly center. And until I get it perfectly center, that thing really likes to jump around due to all the various forces it's interacting with right now. So, something like that, I can't really quite do it with one hand right now, but I had it perfect earlier. But that's an easy way to do it. I've got this one essentially closed up and just running 5 volts from the power supply now. I can now sort of fine-tune the alignment, and what I did was I super meticulously tried to line this up using various ways to where I thought it was absolutely perfect. and then I held it in that place as good as I could, the top and the bottom pieces, while I glued it together. And of course that wasn't going to be a perfect end result, and what I was left with was it was still crooked again. So in this case I'm just going to have to offset some of the magnets with some other pieces of metal. You can see I've got a couple screws hooked on right there, and that's actually pulling it closer to where it needs to be. And in this setup, unless that thing can actually come down and sit dead center and just rest there, this ain't gonna work. And like I say, there's lots of different ways you could try to work this out, but I'm pretty sure human imperfections are going to make it too difficult. So some fine tuning in the end is probably going to be required. And as you can see, it kind of throws it off. It wants to pull over closer to those screws because I've thrown the what I thought was a perfect balance off. But as long as I can get that to sit about where it's supposed to be, then it has a better chance of maintaining stability. And right now I still need to tune back the sensitivity on here so I can get it to free spin like that. But right now it doesn't want to because it's not totally center and it's got too much imbalance going on. So if I can fix that, then it'll be good to go. And even now it's not freaking perfect. It's starting to piss me off, but there's really nothing I can do about it. That's about as perfect as I can get it. Everything is not perfectly centered, but all the forces are working with each other right now to where it's about as good as I can get it. Now, also, that magnet is not perfectly balanced because it's weighted on one side a little bit, missing a chunk. So I don't know, maybe that's got something to do with it. Now with this one, I don't know if I'll be able to do it while it's running, but the trimmer on here, essentially, if I cut the trimmer up, it's decreasing the amount of resistance. So technically you can look at it like very finely tuning how hard that transistor is cutting on given that particular distance and where the sensor is at. So what I try to do is cut it all the way back to the point where it just barely doesn't want to hover, and at least that way, while it's in quote idle mode, or when it's not actually floating a magnet, it's pulling the most juice, it'll be pulling as minimal juice possible, because what I want is the least amount of juice being pulled. But I can turn this thing down a whole lot. Twist it. Now, assuming I can still get it to float, yeah, so it'll still go. So let me see if I can actually put a meter on here just to double check to make sure I remember this right, because it kind of feels like it's pushing a little harder now. Alright, well, I can't really crank it on camera, but I've cranked it down to the point where it's pulling approximately 14 milliamps with the magnet sitting close to where it would. Now this clamp is probably not the way it goes. It's a little iffy, but just to show. So where it's set now, I've cut it down to the point where it will not lift this magnet anymore. It just won't do it. Doesn't have the juice. Now you see it's still just barely doing it. I just managed to get it, and now it's running at about 40 milliamps. So that's probably the lowest amount it will run off of. It takes very little to plop that down. Now when I take the magnet off and it runs full blast, you can see it's bumping up closer to a damn amp now. It's really closer to probably 500 or so. Now, because that's too difficult to get going, I need to give it some more juice. So I'm going to back that trimmer down now and see what happens. So we were at about 40 milliamps running. So I've cranked it back a little bit, and now when I get it going again, it is running at now closer to 65 milliamps. So it went up a little bit. So it's about 25 milliamp difference, which I guess is pretty significant here. But watch the relationship where now that I've changed that around, let's see what it quote idles at, which would be closer to around 6.5. So you can see when I crank that up or down, it gives me a higher or lower idle and run. So while it takes a little, it runs off a little more juice now when it's balancing, it idles at less current. When I run it from even less current, as far as levitating the magnet, then it idles at more current. So, 70 is not bad. That gives me the ability to where it's got a little bit of push in it like that. I can push it up a little bit more. I wouldn't mind maybe running it closer to like 100. But at least this way, it's got, a little more leeway and play in it, to where I can knock it around a little bit and you can see it bounce around and it's not going to completely fall. That's pretty cool. So actually, let me see how high I can bring it. Alright, so I was able to bring it up to about 100 milliamps tops. We're about 90. And thing is being levitated at the maximum it will, but that's only because of the resistances I set in the circuit and the trimmer that I used. But at least now it'll sort of relatively spin. Now I still need to get it perfectly centered and use a perfectly centered magnet, but at least now I'm able to accomplish what I was doing with my other one, running off the Arduino, where I can spin it around. You can see it eventually gets out of whack, and it just fell. But that's because of this chip, this slight chip in that magnet. It's actually throwing off some imperfect fields there, an imperfect field. But yeah, it's not as easy to get going as the very first one I made. Requires more power, but at least I don't need an Arduino, and that's pretty cool. After playing with these, let me get this one going in. This one don't stay on because I'm using a power bank I made with a circuit will shut off automatically if it doesn't sense a load, and the load is so small that the Arduino is pulling that it just doesn't even treat it like it's doing anything. So that'll shut off fairly quickly. But this one's, I didn't have to change the AA driving that coil until 24 hours after I put the first battery on, which was actually reading a half dead when I put it on the charger. Just to see where the voltage was at. So I put that half-dead battery on here to run this, and finally went down to a little under a volt to where this thing stops, and now this one's on its way. But the main differences between these two I noticed, well, this one's still using the good old Arduino for simplicity, and the supply just cut off because the Arduino pulls hardly anything. The distance that this thing is getting for the amount of juice that it's pulling is crazy to me, and I'm not really sure how it does it. I have to investigate that some more. But then if I look at this one, it doesn't quite have the distance as that one does. But I was basically able to figure out that it all comes down to the balance. Without getting everything balanced just right, and I don't mean perfectly symmetrical either. Perfectly symmetrical is when you do that, you're relying essentially on the assumption that every single piece of material that you're using is identical, which is not always going to be the case. Not every magnet might be perfectly identical. They might look it. Little things like that, but the end result of your balance is just going to be probably due to playing around with it. And even so, this is not perfectly balanced. You can see it's not sitting perfectly in the center, but when you look at it from the sides, it's almost perfectly plumb aside for the imbalance in that magnet, and that's from both sides. And that was necessary to get this to work, and the amount of power that this is pulling is way more than what that one pulls when it runs. So like I say, this one, what I'm probably going to do is buy a smaller Arduino board, program it the same way, add a few more features, LEDs, things like that, and that'll be a done wrap. This one, I'm still probably going to turn into a battery operated deal. But there's other things I need to add on here for safety purposes, because if that thing was to do anything other than what it's supposed to do, which is this right here, now when it's doing that, the transistor is essentially off and it's pulling hardly anything, you know, milliamps, 20 milliamps tops. When it flies off and sticks over there like that, and you see that green light come on, well, that's when that coil is being immensely overheated, and it's not going to take long for that thing to get so hot that it starts melting everything in there. So I need to use a thermistor or some type of temperature sensor in there. I've got some actually, like, see, I got one laying right here actually. This is a temperature switch, but this one is normally closed or normally open, so I use this to cut fans on when things get too hot, and that's not going to work out for this situation. So like I say, once I figure that out, figure a good little battery to run it from, and it'll run from a very long time from a small battery, so long as it is balancing. There's a couple of things. I even tried to throw a reed switch in there in the perfect spot so the circuit itself wouldn't come on unless the magnet was sitting where it needed to be. But I had too many crazy magnetic fields going on inside that chamber there for any type of magnetic switch to work properly, so it's going to need something else. But yeah, I almost want to challenge people out there to try to make these little ones from the bottom platforms, because while it's not impossible, it is actually easy once you figure it out. It's like a huge learning process.